Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You can also always join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our 5th week of our 9-week course. Next week is March break, and we will not be broadcasting, so take a break, have a rest, enjoy life in general. And come back to us on March 20th is the next day that we will be broadcasting. We are now about halfway through our course timeline, so it's really good to be submitting work for marking. So a reminder that the support questions, the ones with the little pencil icon, are not for marking. These are practice problems, and you can decide which ones and how many to do depending on your needs. If you're understanding a concept, it is totally okay to skip questions, though I do strongly encourage you to do the practice problems and to make sure that you are really comfortable with them before handing in your key questions. The answers are in the back of the booklet for the support questions, so check them out to make sure that you are on the right track. And if you are struggling with anything, let me know so I can support you. The key questions, the ones with a little key icon, are the ones to submit for marking. So please do all of these questions, showing all your work, your steps, and your thinking. This way, I can understand what it is that you understand, and I can give you par marks if you are struggling with something, but you have part of it right, or you just make a calculation error. The more information, the better for me. So how do you submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work just like taking a picture. And Apple devices have the Notes app that has a scan function, and Android devices have a Google Drive app that has a scan function. Like I said, it's just like taking a picture, though it simplifies the image to make it a little bit of a smaller file, and means that you can put multiple pages into a file, and then it's easier to send. If you do need help to learn how to do this, on my YouTube channel, there are tech tutorials that walk you through step-by-step how to do this. Also, you're welcome to ask if you want some more support. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is bslate.wahsa. The second method is to drop it off in Sioux Lookout. If you're in town, we have an outdoor mailbox at 74 Front Street. We're the bright red building next to the post office, and have a small white mailbox next to our side entrance. So feel free to just put that in your work in there at any time. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. Students can also send their work by fax, but just let us know that it's coming so we can make sure we keep an eye out for it, because sometimes things get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslate.wahsa. All of our radio Zoom classes are recorded, and I upload them shortly after broadcasting to YouTube, and then I share them on Facebook. So this is a really easy way to find all of our lessons and be able to review all of the course material. Also, in the playlist that we have, which is MBF3C, our course code, there are short videos that explain common errors and confusing concepts. So if you're struggling with something that maybe isn't actually one of our course materials, but it's a building block to get you there, it's a good place to check it out in case there's something there that can help you. Math is a really visual subject, so I strongly encourage you to access the visuals, access the videos. Either joining me live from Zoom, you don't have to talk to me, that is fine. You can just watch, no worries. Or you can watch the replays on YouTube on your own time, where you can pause things, slow things down, take a break if you need to be. Those are great options. If for some reason you don't have reliable internet or something and you don't have access to these options, let me know, and I'm happy to send you a copy of the recordings so that you get the full experience. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. You can give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Also, you can connect with me through Facebook, where my name is B-Slate Wahsa. Remember, my office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today's lesson is lesson 12, and we are going to be looking at the law of sine. So we've covered primary trigonometry, we covered those first three trig ratios, sine, cosine, and tangent with right angle triangles, and now we're going to be moving on to things a little bit more complicated. So our learning goals are that at the end of this lesson, you'll be able to interpret information and then draw and label diagrams. This is a really important skill to have. And you will understand how to use the sine law to find unknown sides and angles. You know you've met the learning goals because you can label triangle angles and sides. You can explain when to use the sine law, and you can solve for unknown sides and angles using the sine law. When will you use this in real life? Well, we're building what I call brain muscle. So the same way that if you are building physical muscle and you lift weights, you lift barbells over and over and over again, most likely in life, you won't have to lift barbells for a particular reason, but that action is building that muscle so that you're able to strengthen that muscle and lift other things and have stronger arms depending on when you need them in different places. So it isn't the action of lifting weights isn't so that you're not practicing lifting weights so that you can lift weights more in life. You are building muscle so that you can do other things in life. So the same thing with our brains is that though the sine law might not be something that is a tool that you need in life, thinking and engaging and critically thinking and problem solving, which is what we're going to be doing through this lesson and throughout our course, builds brain muscle, which means that it's easier for you to think critically and problem solve in other ways, even if they're not related to the exact concepts that we're doing. But first, let's activate our brain with some mental math. Hopefully by now you realize that I'm not a fan of bad math minutes, as they cause stress and anxiety in students and don't really teach them anything. And so instead we focus on developing strategies that are focused on comfort and confidence and friendly numbers in order to set you up for success. Our question today is 318 times 74, and we're going to be using the strategy of partial products. I really like partial products because though it is very similar to the traditional algorithm that we're all taught and expected to just always use, it shows us what's going on and it makes so much more sense. We don't lose place value and our numbers actually are our numbers. So how we do this is we're going to break our numbers into place value. So we have 318. So that's going to be 300 plus 10 plus 8 is what 318 is expanded to. And then 74 is 70 plus 4. So then everywhere we see a plus sign, we're going to draw a line. And this just helps us keep ourselves organized. So we can see we have 6 boxes inside of our organizational tool. And that means that we're going to have to do 6 different multiplication steps in order to keep ourselves. So that just helps us organized. So now I have 300 times 70. Well, I know that 3 times 7 is 21. And then I have 3 zeros. So I'm going to have to increase that by a factor of 1,000. So that's going to be 21,000. So that's hopefully straightforward. Then I have 10 times 70. So that's going to be 700. And then I have 8 times 70. Well, I know 8 times 7 is 56. So 8 times 70 is 560. This method doesn't help you if you still struggle with your multiplication tables, then this method isn't necessarily the great place to start. But it's a tool for if you have your multiplication tables as a tool, if that you're comfortable with, then you can use it to multiply bigger numbers. 300 times 4, well, 3 times 4 is 12. So that's going to be 1,200. 4 times 10 is 40. And 4 times 8 is 32. So now I have all of these parts and I can add them up. Now I can add them up however I want in order to make them friendly. I don't have to add them in any particular way. So I see here that 560 and 40, well, 40 and 60 is going to be 100. So that's going to be 600. Okay. So then I see 600 and 1,200. Well, that's going to be, I can see that that's going to be 1,800. And this is really more about doing this in my head than about doing this on my screen, which is why it's messy looking, and that's fine, because I'm really just tracking in my head. And then I say, okay, well, 1,800 plus, I know that 800 plus 700 is 1,500. So 1,800 plus 700 is going to be 2,500, so 2,500. So then 2,500 plus 21,000 is going to be, so I combine those two, I'm going to have 23,500. And then I still have this 32 over here. So I have 23,532 is what that multiplies to be. So I just drew a bunch of lines that make it much more confusing looking, but that was just me tracking the addition that I was doing. You could have written them all down and added them all up. That would have been fine too. But again, this is one of those, you do them the way that it makes sense for you in order to complete the question. So there's multiple ways of doing it, and you figure out which way is best for you. Okay, so that's partial products, which is a really useful tool, I find. Mine's on. What prior learning do we need to know today for this sine law problem? So we're going to need another way of labeling our triangles. This is different than when we were labeling our triangles for the primary trigonometry ratios that we're talking about. This is another practice for labeling triangles. So the vertices, which are the corners of a triangle, we label with capital letters. This is the practice for standard practice for math, is that we give them capital letters. So here I've labeled them D, E, F. My corners, my vertices are labeled with capital letters. The sides are lowercase letters. Again, standard practice in mathematics, just to keep ourselves organized. Then the key is that the opposite vertices and sides have matching letters. So you can see here that the small d is across from the capital D, the small e is across from the capital E, the small f is across from the capital F. And that is super important for what we're doing for this lesson, for the sine law, and for our next lesson, the cosine law. It's super important that you label your triangles this way in order to be able to use our laws. So we'll come back, that is going to keep showing up, but you need to know that, you need to believe that that's just a practice that we've just decided, but you need to label your triangles that way. Okay, what new concepts do we have to look at? Well, this sine law that we're going to be using, which again is something that seems arbitrary and who cares, fair enough, but it is something that shows up in various places in different applications in the world. So here's a few examples where it shows up. Trying to figure out how far a forest fire is from a ranger's tower. So this information is using some tools, is how we can figure out, a ranger can figure out how far a forest tower is away from them or away from a water tower in order to be able to deal with that fire. Hanging things from the ceiling, and you wanted a certain height, using the sine law, it can help you figure out to position things exactly where you want them. And in planes, they need to take into account wind speed. and therefore how to end up where they want to be based on flying into the wind slightly by how much in order to end up where they want to be. So the sine law as part of that can be figured out. So first, we're going to go through some conceptual understanding. This is not in your IELTS booklet, and you're not going to be tested on this. You do not have to know it, but I know that some folks really learn best if they understand the why behind things. If you just want to know the rule and you just want to follow the rule without understanding why, you can. We're going to go through the rule as well. And your IELTS booklet focuses, it just gives you the rule and then shows you how to fill in the blanks and get an answer. But this part in our lesson today is looking at why the rule actually works. It proves the rule. If that's something that's useful for you, go for it. If not, and you want to skip over it, if it's just going to confuse you, that's fine. You know yourself best and what skills and tools you need. So why does the sine law make sense? We have a triangle, any triangle, doesn't matter. It doesn't have to be a right angle triangle. Most of the time, it is not a right angle triangle. Because if it was a right angle triangle, we would use those primary trigonometry ratios from lesson 11. So we have a triangle. We're going to label it A, B, C as our vertices, which means we're labeling our sides A, B, C as our sides, corresponding to the opposite sides, so the opposite vertices of the same letter. And what we're going to do is we're going to do what's called dropping a perpendicular. So I'm going to go, so C is my vertice that is at the top of my screen. And I'm going to cut my triangle into two triangles by drawing a line from C straight down so that it's perpendicular to my line AB or C, the small c. So this orange line here, as you see, I have the perpendicular symbol, is perpendicular to this blue line C here. And I'm going to call it H for height. Just what I'm doing it, we call it something else. I want to call it H for height. So now I have two triangles. I have this light green triangle and this light pink triangle. So my big triangle that's outlined in blue, I've broken up into two smaller triangles. So now I'm just going to look at this light green triangle. And I'm going to call the point, the new vertice that I have, D, just so that we have a name for it. Okay. So A is my reference angle. And I can see that H is my opposite and B is my hypotenuse. So from the primary trigonometry ratios that we looked at lesson 11, and if you haven't done lesson 11 yet, go back and do that first. We can see that sine of A is equal to opposite over hypotenuse, which is equal to H over B. So H, if I just want to figure out how to figure out the length of H, that is B times the sine of A. Okay, hopefully you follow that. Now, if I look at my pink triangle, the other half of my big triangle, D is still my corner, right? Because that point is still the same point. H is still the same part. It's just that I'm looking at the other side of it. So now I have angle B is my reference angle. And I still have H as my opposite. And now A is my hypotenuse. So sine of B is equal to opposite over hypotenuse, which is equal to H over A. So again, H, I can say, is equal to A times sine B based on this triangle. But what I notice is that both these, in these two triangles, H is the same thing, right? So it's the same line. It's just that we looked at one half of the triangle and the other half of the triangle, but H is still the same line. So H is the same amount, which means that B times sine A is equal to H and A times sine B is equal to H. So that means that they're all equal to each other. So I can ignore the H, which I don't know anything about. And I can say that B times sine A is equal to A times sine B, which then if I want to rearrange, and I can divide both sides by A in order to cancel off the A. And then I have B times sine A divided by A is equal to sine B. And I can divide both sides by B to cancel off the B. And I end up with sine A divided by A is equal to sine B divided by B, which is what our sine law is. We'll look at it in a minute. So we could do the exact same thing if we cut our triangle through any of the vertices. So if instead of doing through C, if I go from B to line B, and I put a perpendicular there for my height, I've got two different triangles, but I'm still going to get the same thing. I'm going to get sine A over A is equal to sine C over C. Or if I go from my vertex A to my side A and put a perpendicular line, again here, I have two different triangles, but if I do the same process, I'm going to end up with sine C over C is equal to sine B over B. These ratios are all the same. So here, because sine C and sine C is the same, we can see that sine A over A is equal to sine C over C, which is equal to sine B over B. These are all the same thing. Remember, we're saying that the ratio is the same. We're not saying that the lengths are the same. We're saying that the comparison of the ratio is the same. So generally, we write this in alphabetical order. So we're the sine law, which says sine A over A equals sine B over B equals sine C over C. And that's what the sine law is, which is what they give you in your IL booklet, but that's how we get to that point. So let's look at the sine law formula and see how we actually use it. This is on page 21 of your booklet. This is where your booklet starts. Okay, so when do we use the sine law? So we use it for any kind of triangle. It does not have to be a right angle triangle. It can be, but it's more straightforward to use the tools that we learned in lesson 11 for a right angle triangle. The sine law is when we have any kind of triangle. But the things is that we need to know two angle measures and one side measure. So here's a triangle where we have two angles and a side, and we're looking for another side. We can use the sine law to figure out that other side. It doesn't matter which side we know or which we don't know, because if we have two angles, we can always figure out the third angle, right? Because remember that a triangle angles equal 280 degrees. So if we know two angles, we can always figure out that third angle. So that is the one way that we can do this. The other way is that if we know an angle measure and two side measures, as long as one of the sides is opposite the given angle, we can use the sine law. So what does that look like? So here I have a triangle and I have two sides and one angle. The angle that I'm finding is across from one of the sides that I know. And the angle that I know is across from a side that I know. So we need that information in order to, we need those connections. If we don't have that connection where we have a side and angle that we know, we can't figure out, we don't have the tools, this won't work. So here, if you look, we have a triangle. Sorry. We have a triangle where we have an angle and we don't know the side across from it. And we have a side and we don't know the angle across from it. Well, we can't figure out that third angle. And we can't figure out the side. We just don't have enough information. So we can't do it with the sine law. Okay, we will learn another tool that we can do it for, but right now we don't have that tool. So we have to have a side across from an angle if we know two of the sides. Okay, so how do we actually use this? How do we actually apply it? So we have a triangle ABC, and I have angle A is 72 degrees. So what we're going to do is we're going to first label our sides. So I see that angle A is 72 degrees. Across from that is side A, which is 18 centimeters. I see angle C is what I'm looking for. And so across from side C is 15 centimeters. So I can use the sine law because I have two sides and one angle that is across from one of the sides. So as we've talked before, I like to write out my rules at the beginning so that I keep myself organized. So I'm going to write out sine A over A equals sine B over B equals sine C over C. I'm probably not going to write the whole thing out. I don't have any information about B, so it's not useful for me. I can just pick sine A over A equals sine C over C. Then I fill in my values. So I have sine C divided by 18, sine 72 divided by 18 equals sine C divided by 15. This is why it's super important to label your triangles correctly so that you can fill in the values in the right place. If you mix them up, you're going to get the wrong answer because your ratios are going to be wrong because it's based on the fact that they are labeled with the same letter. So then I isolate for sine C by multiplying both sides by 15. And I get sine C is equal to 15 times sine 72 divided by 18. And so I can do that calculation. Remember, when you're doing this, round to at least 4 decimal places if you're going to write it down. So that's 0.7925. Also, remember your calculator must be in degrees. That is still true. That is always true in our course. We're not doing anything else, so it has to be in degrees. So then I do sine inverse of 0.7925 equals sine inverse of sine C in order to cancel out my sine. Remember, if this isn't something that you know how to do or you know what I'm talking about, go back to part 2 of lesson 11 to figure that out. So that means that angle C is equal to 52.4 degrees. And that's how we use the sine law to find an angle. So we can also use the sine law to find a side. So we have another triangle, ABC, and I have angles. So I have angle 39 at B, which is across from side B, and I have angle 65 across from 30 meters, which is side A. And I can use the same formula. I have A and B, so I'm going to do sine A over A equals sine B over B. And I'm going to substitute in my values. So sine 65 divided by 30 equals sine 39 divided by B. Now I need to isolate for B. So I need B on the top. We can't be divided by B if that's what I'm isolating for. So I multiply both sides by B. And then I multiply both sides by 30 in order to continue to isolate for B. And then I divide both sides by sine 65. This is all just algebra. So I end up with B equals 30 times sine 39 divided by sine 65, which is 30 times 0.6293 divided by 0.9063. So that means that B is equal to 20.8 meters. These steps in here are just algebra, which at this point, hopefully you're comfortable with. If you're not, then let me know so I can help you with the algebra part. That's not what we're learning at this point. So I'm not spending a lot of time on it. Your calculator still needs to be in degrees. I'm going to keep saying it until you believe it and have it like that all the time. Now, we can do this a little bit different, so we have less algebra to do. So we're going to pause and we're going to do an aside to think about what our other option is. And we're going to do what I'm going to call flipping proportions. So let's look. If I have a bunch of ratios that are equal to each other, so I have 1/2 is equal to 3/6, which is equal to 5/10, which is equal to 12/24. Those are all the equivalent of 1/2, right? That's true. Yes, hopefully you're good with that. If I flip them all and I have 2/1 is equal to 6/3 equal to 10/5 equals 24/12. This is also true. These all equal to 2. the final answer is not the same as what was before. Before it was 1/2, now it is 2, but the relationship is all the same. That's what we're looking for. The relationship between these numbers are the same. So what that means, how that's useful for us, is that we know that sine A divided by A equals sine B divided by B equals sine C divided by C. We proved that. That is true. So if we flip it, if we have A over sine A equals B over sine B equals C over sine C, this is also true. The ratio is still the same. The numbers are going to be different. The result is going to be different, but the relationship is still the same. And that's what we need to know. So that means that we can use that information in order to find a side. So still, we have our same triangle, 39 at B across from side B, 65 degrees across from side A, which is 30 meters. But this time, instead of using the sine A over A formula, we're going to use A over sine A equals B over sine B equals C over sine B. So now our side that we need to know, our side A and B, are on the top. So when we fill in our variables, our substitute in for our variables, we have 30 divided by sine 65 equals B divided by sine 39. And when we do the algebra, we just need to multiply both sides by sine 39 in order to isolate for B. So we get B equals 30 times sine 39 divided by sine 65. We get to the same place. If you go back to the previous time that we did this example, this is the same thing. We still get 20.8 meters. We get the same answer, but we have less steps to do for the algebra because the algebra has already been done by us by flipping the formula. So it just means your steps are a little bit simpler. You can use both methods. I don't have a preference. It doesn't matter if I did. You decide what works best for you and you use what makes the most sense for you. So how do you know which formula do you use? Like I just said, you could use either formula at any time the sine law is required. So anytime that you know the sine law is the best tool for you to use, you can use either formula. It's the same formula, just sort of different iterations of it. But if you want to do less algebra, then when you're solving for angles, use sine A over A equals sine B over B equals sine C over C. Have the angle variable on the top. When you want to solve for sides, use A over sine A equals B over sine B equals C over sine B. Have the side on the top, the side variable on the top. This is going to make it so you have less algebra to do. Okay, you again decide what makes the most sense for you and what is best for you. It doesn't matter to me. I'm just giving you different options. As always, your calculator must be in degrees. That is not an option. That we are talking about the unit of measurement of degrees, so it has to be in degrees. That is key. Okay, not negotiable. All right, now you can do the support questions on page 24, questions 1 through 9, hopefully. Let's do some practice questions together to get you set up so that you can hopefully do those support questions by yourself, as this is kind of tricky. So, number 1, we are asking to solve for the unknown. So we need to figure out what we don't know and how to solve for it. We have a triangle, great, ABC. We have one angle, 47 degrees. So across from that is my side A. So 4 is my side A. Then I have this is indicating that that's the angle that I want. So I'm trying to find angle C. That's what I'm looking for. And across from that, I have side 5, which is equal to my side C. Okay, so I have 2 sides with an angle across from one of those sides, so I can use a sine law. I am looking for an angle, so I'm going to use the sine C over C equals sine A over A orientation of the formula because I'm looking for an angle, so I'm going to put the angle on the top. It doesn't matter. I could have put sine A over A equals sine C over C in that order. It doesn't matter. I just put what I was looking for at the top because that helped me keep myself organized. Now I'm going to substitute in what I know. So side C, I don't know. My side C is 5. Sine A is 47 degrees. Small a, my side A is 4. So that means that sine C is equal to 5 times sine 47 divided by 4. There are various ways for you to write that down. So you can, as always, you can choose what worked best for you to write down. So 5 times sine 47. Sorry, I typed that in. I should press sine 47 and then divided by 4, which gets us 0. So sine C is equal to 0.8839 because I'm going to round up. So that means that angle C is equal to sine inverse of 0.8839. I'm not writing out all of my steps just because I don't have the space. You can write all the steps. That is fine. You decide what is best for you. So then we go to function to find our sine inverse. And then we can put in 0.8839. And we get 62.1 degrees. So angle C is equal to 62.1 degrees. So there we go. We solved for the unknown angle, which is what we needed to do. Okay, next question. Solve for the known. In triangle DEF, solve for F given angle D is equal to 66 degrees, angle F is equal to 39 degrees, and E is equal to 10 meters. So in this kind of question, they don't draw the triangle for you. I still like to draw the triangle as that makes the most sense for me to help me visualize. You don't have to, but that helps me know what it is that I know and what it is that I don't know. So my triangle, I don't need to draw my triangle exactly. It is okay if my angles are wrong. I don't care about that. I just want a visualization. So I'm going to draw a triangle, D, E, F. And I'm going to say, okay, so D is 66 degrees. Angle F is 39 degrees. And side E, which is here, is equal to 10 meters. So now I look at that and I say, oh, and they're asking me to solve for F, side F, which is over here. And I can say, well, do I have a side across from an angle that I know? I don't. So I need to figure out this angle over here. This angle I need to figure out first before I can use the sine law. So I do that by going 180 degrees, take away 66, take away 39 is going to give me what I need to know is going to give me angle E. So having drawn it helps me know that that's what I need to do. Again, you don't have to draw it. That's not what you, but drawing it helps me see that. So angle E is 75 degrees. Okay, so I strongly encourage you to draw it, but you do what's best for you. Now, I am solving for side F. So I'm going to put F on top and then sine F on the bottom equals, and I know E, so I'm going to put E on top, sine E on the bottom. Now, my letters have changed, but as long as my letters correspond to each other, it doesn't matter what my letters are. They're just placeholders. So now F is what I'm looking for. So then sine F is sine 39 is equal to 10 over sine 75. So then F is equal to 10 times sine 39 divided by sine 75. And we can do that on our calculator. So 10 times sine 39 divided by sine 75 equals, don't know what you're doing, equals 6.5 meters. So F equals 6.5 meters. And that's how you find a side. All right, number 3, explain why the below triangle cannot be solved using the sine law. We have a triangle L and M, and we know the 3 lengths of the sides. Because we don't know any angles, we can't use the sine law. We have to have an angle. We'll learn how to solve this using a different law, but we have to have an angle to use angles. We have to have an angle in order to use the sine law. So we only need one, but we have to have it. If we don't have any angles, we can't use the sine law. All right, and then we have word problems, which can be daunting. So if you don't have a picture, draw yourself a picture. If it gives you a picture, use the picture. So 2 guy wires are 27 meters and 15 meters in length, are to be fastened to the top of a TV tower from 2 points B and C as shown. So we have, this is here, our TV tower. We have 1 guy wire that's going all the way to point B, that's 27 meters. We have another guy wire that's going to point C, that is 15 meters. That's what we know so far. So the first thing it asks us is how far apart are points A and B. So what is distance A? So with this type of question, sometimes you don't have enough information to start with and you have to do some steps to get there. So I'm looking for A. Do I have angle A? No. In order to use the sine law, I need angle A. So I'm going to have to find out some more information first. I have angle 32 and side B, and I have side C. So I could find side or angle C. If I do that, then I can figure out what my angle A is, and then I can figure out what my side A is. So I'm going to find out sine C. So sine C over C is equal to sine B over B. I'm going to fill in what I know. So sine C, I don't know. So divided by 27 is equal to sine 32 divided by B. So sine C is equal to sine 32 times 27 divided by, sorry, I did write in what my B was. 15. I looked, I just didn't write it down. Okay, so I'm going to do this in one step just for the sake of time. So I'm going to do sine 32 times 27 divided by 15. So that is 0.9539. And then calculators can hold that information in their heads. So I'm going to go sine inverse, and then I'm going to put in my answer. So you have to figure out how your calculator might be able to do that for you. And that gives me that angle C is 72.5 degrees. So that information I can then put here. And now I can figure out what angle A is, because angle A is 180 degrees. take away 32, take away 72.5. So if I do that, so I get 75.5 is what angle A is. And I like labeling it as I go so that I then have that information. Now, have we actually answered the question? No, we have not. So we need to go back and make sure that we answer the question. Why won't it go to where I want it to be? So I'm going to erase all this information because I need space to write down what I'm actually trying to find, because I'm trying to find A, small a. So now I have A and I know the angle across from it. And I can use either of the other sides that I have. I'm going to use B because B, both parts were given in the question. So this way, if I made a mistake with C, I'm referring back to something that was given to me in the question. So A is equal to sine of 75.5. And that's equal to 15 over sine 32. So A is equal to 15 times sine 75.5 divided by sine 32. So A equals, we're going to use our calculator, 15 times sine 75.5 divided by sine 32 is equal to 27.4 meters. So side length A, the distance between the two poles, is 27.4 meters. That's what the question was looking for. So sometimes you need to do a bunch of steps in order to get to the point that you actually were looking for. Then next, they ask you, how tall is a tower? And so here, so that's the H. Here, do you need to use the sine law to figure that out? No, you don't, because you have a right angle triangle. You know an angle. You're looking for the opposite. You know the hypotenuse. So you can use that sine 32 equals H over 27. So 27 times sine 32 equals H. So the height of the tower is 27 times sine 32, which is 14.3 meters. So all of these questions can get a little bit mixed up. You don't have to always just be using the sine law. You can use any of the tools that we already have. So that's just something to be aware of. Okay, let's quickly consolidate as we are out of time. So lesson 12 has been the sine law. Remember, you have to label your vertices with capital letters and your sides with lowercase letters, and then they have to match the opposite sides. This is super important to get everything organized properly. That we use the sine law when we know two angles and a side, or when we know two sides and an angle that are opposite one of the sides. Also super, super key. That we can use both versions of the formula. It's the same formula, just two different versions. But if you want to solve it easier with less algebra, use the sine A over A equals sine B over B equals sine C over C for angles, and use A over sine A equals B over sine B equals C over sine C for sides. So hopefully you're confident in your ability to label these triangles, angles, and sides. You can explain when you need to use the sine law, and you can solve now for unknown sides and angles using the sine law. It does take practice, so spend some time practicing. So if you have any questions about this lesson, or of course any of our other lessons, give me a call at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.owen.ca, or a Facebook message at bslatewasa. Remember, my YouTube channel is B-Slate Wahsa, and our playlist is MBF3C, where this lesson and all of our previous lessons are up. So you can check those out if you need some help. Hope you have a lovely March break. Thanks so much for joining me today. Gwitch.